So this is our inclined plane assessment. The scenario we have is that a block weighing 3.7 kilograms is on a plane at 18.9 degrees. We are going to do four things. We want to draw and label all the forces that are acting on the block. We want to calculate the force provided by the friction, since this block is motionless, and we want to calculate the normal force between the block and the ramp. In addition to that, we are also going to calculate what the acceleration would be if this was a frictionless surface. So we're going to start by drawing our force diagram, and the first force we have is coming from the Earth, mg, which is the force that the Earth pulls on the block. It's going to be mass times the gravitational field strength of the Earth, which is 3.7 kilograms of the block, times 10 newtons per kilogram, which is the gravitational field strength of the Earth, or 37 newtons for our mg. Next, we're going to draw the normal force. This is perpendicular to the surface, so that angle is perpendicular to this, and we don't know what that is, so we're just going to leave it unlabeled at the moment. We also have friction, which is going to be going in the opposite direction that the block would want to slide if this was a frictionless surface. So to calculate our normal force and our friction, we're going to draw a little triangle in here to mg, and our hypotenuse is going to be mg, and we also know that this angle is going to be 18.9 degrees because of the geometries of this triangle. We're going to label this as x, and x is going to be the same as our friction from the block, and we're going to label this side as y, and y is going to be the same as the normal force on the block. In order to calculate x and y, we're going to use trig. So we're going to do the sine of 18.9, our angle, is going to be equal to x, the opposite side, over 37, the hypotenuse. When we calculate that out, x is going to equal 12 newtons. When we get, so we know that 12 newtons is going to be equal to the friction on the block. To calculate the normal force, we're going to use trig again, but a different identity, cosine. We're going to use cosine of 18.9. It's going to be equal to y over 37 newtons, which is y is the adjacent side over 37, the hypotenuse. Working this out, we get y is equal to 35 newtons. So we know that since y and the normal force are the same, we know that the normal force is going to be 35 newtons. To calculate the acceleration, we're going to, so if this was a frictionless surface, this friction would not be here, and thus the block would have an unbalanced force on it of 12 newtons in the opposite direction of that friction, because the friction used to be balancing it out, but now there's no friction, so the block will have an unbalanced force in the opposite direction of the frictional force. So we know we can use the equation acceleration equals the net force over mass, and then acceleration equals 12 newtons, which is our net force, and also that net force comes from our friction force, over 3.7 kilograms, which is the mass of the block. That acceleration, once we work it out, is going to be 12 newtons over 3.7 kilograms. And our acceleration will equal 3.24 meters per second, or per second squared.